It is my understanding that the objective is to demonstrate that the height, quotation marks intended, of the state on the sphere, specifically the z-coordinate, is a direct and linear readout of the measurement probabilities. By the conclusion of these 4 steps, you shall observe that 1. Z equals cosine theta. This represents the geometric projection of the Bloch vector onto the vertical axis. 2. P of 0 equals cosine squared of theta over 2. This represents the quantum probability derived from Born's rule. 3. P of 0 equals 1 plus z over 2. These two expressions are mathematically identical owing to a half-angle identity. This signifies that complex mathematical operations are not required to ascertain the odds of a measurement. One may simply observe the vertical displacement of the point upon the sphere. Shall we commence with the derivation? It seems this formula is the recipe, shall we say, for any pure quantum state on the sphere. The coefficients, cosine of theta over 2 and e to the I. The 1 over 2 factor is the bridge between the 3D geometry of the sphere and the mathematical geometry of the Hilbert space. On the sphere theta, ket 0 and ket 1 are 180 degrees or pi radians apart, opposite poles. In math theta over 2, ket 0 and ket 1 are orthogonal, 90 degrees or pi over 2 radians apart. If we didn't divide by 2, then moving from the north pole, theta equals 0, to the south pole, theta equals pi, would move us too far in the math. With the 1 over 2 factor, when theta equals pi, the formula uses pi over 2, which correctly makes the ket 0 amplitude 0, cosine of pi over 2 equals 0, and ket 1 amplitude equals sine of pi over 2 equals 1. Would you like to move to the next step to see how we apply Born's rule to these amplitudes? The Born rule serves as the vital bridge, the connective tissue, if you will, between the intangible quantum state and the concrete results obtained from measurement. It posits that the probability of achieving a particular outcome is defined by the square of the magnitude of its amplitude, expressed mathematically as P of n equals the absolute value of the inner product of n and psi, that quantity squared. In the specific instance we are addressing, given that the amplitude for ket 0 is cosine of theta over 2, the probability of measuring 0 simplifies to cosine squared of theta. In this formula, n is the measurement outcome you are looking for. For a qubit, n can be either 0 or 1. 0 and 1. These are the two basis states that represent the possible results of a measurement in the computational basis. The amplitude alpha. For each outcome, there is a di psi ye is the state vector of the qubit. It's the mathematical arrow that represents all the information we have about the quantum state. Linear combination.